Now we are going to talk about how the photoelectric current varies with respect to the potential difference which is applied across the cathode and anode. Look at the title. What is given here? Effect of potential difference. What is this? Effect of potential difference on photoelectric current. It means that photoelectric current, it changes, is it clear, with respect to the potential difference. So we are going to see these two terms, very important terms. Are you clear? Potential difference is applied across the cathode and anode. Here photoelectric current is measured here with the help of the milliammeter. Are you clear? So already I have explained about the experimental setup which is required for the photoelectric current, the measurement. Okay. So here cathode and anode are there, both are fitted within the evacuated glass bulb. So here this is the incident radiation. Any appropriate kind of any radiation that should be made to incident on the photosensitive cathode. Here you can apply any alkali metal. So let us imagine that sodium is applied on the coated on the surface of the cathode. So whenever any appropriate radiation with appropriate frequency is made to incident on the sodium metal or any other metal, what will happen? Electrons will be ejected out from the metal surface. These electrons are called photoelectrons. Are you clear? When they reach the anode, what will happen? That due to the flow of photoelectrons, it will constitute a current. That current is called photoelectric current. Already I have explained all the basic idea about photoelectric effect. Now look at the tabular column and other important things. Here the incident radiation frequency should not be altered while varying the potential difference while observing the photoelectric current. Which one should be kept constant? The frequency of the incident radiation must be constant. Initially, intensity of the incident light also should be kept constant. Both the two factors must be kept constant. Which two? Frequency of the incident radiation and intensity of the incident radiation, both of them must be kept constant. Now we are going to vary the potential difference across the cathode and anode. Potential difference means with the help of the battery, with the help of the source of electricity, the voltage across the cathode and anode must be varied. Potential divider arrangement, that is very much useful for changing the polarity also. Not only the voltage value, either it can be increased or decreased across the cathode and anode. Even polarity of the cathode and anode can be altered with the help of the potential divider arrangement. Whenever polarity is to be changed, this arrangement is very much useful. So here I have drawn a tabular column. Here in this tabular column, is it clear? I will explain why the tabular column is opened here. Look at that. Here CEP. What is CEP? Collecting electrode potential. Which one is collecting the electron? Anode is collecting the electron. Anode, it receives the electron. Therefore, collecting electrode potential means here the potential which is given to the anode is called, what is this? Collecting electrode potential. Here let us imagine initially with the help of the potential divider arrangement, how much amount of voltage is given here? 0.2 electron, 0.2 volt is given. 0.2 volt is given across the anode and cathode. Here plus 0.2 volt is given. Are you clear? When 0.2 volt is given, what will happen? Here some amount of electrons will be liberated per second. For example, if 5 electrons are liberated per second means all the 5 electrons, they will be reaching the anode, and then that one will constitute a current. That current will be shown here. Let us imagine, is it clear? The respective current value shown by the milliammeter is 0.078 milliampere. Are you clear? When plus 0.2 volt is given to the anode, it receives all the electron. Is it clear? These electrons, they will have some kinetic energy. Initially they will have very lesser energy, kinetic energy, but the number of electron emitted per second will be a constant. So after reaching that, is it clear, it shows some amount of current that is tabulated here. Look at the next value. In the next value, the voltage is increased. I will show you the increased value. Here the value of voltage is increased to 0.6 volt. So here across the cathode and anode, the voltage value is increased to 0.6 volt. Now what happens? the anode potential will be equal to 0.6 volt plus. So all the same amount of electrons, same number of electrons per second they will be reaching. Again the current value will be exactly how much? 0.078 milliampere. Now you have to understand one thing, that when you increase the anode potential from 0.2 volt to 0.6 volt, the kinetic energy of the electron alone will be increased. Very important thing. Are you clear? Number of electrons per second, it won't be increasing. Since the number of electrons per second is not increasing, the clear current is constant. Are you clear? Kinetic energy alone will increase. When you increase the potential difference, the kinetic energy of the electron will increase. Make a note. Are you clear? So when you increase from 0.6 to 1.2 volt, again the kinetic energy will be still more increased, but the number of electrons per second emitted from the cathode will be same. That's why current is maintained as a constant one. So look at the value here: 0.6, 1.2, 2, 3.4, 4.5, 4.8. In all cases, slowly the voltage across the cathode and anode is increased. Anode potential is increased up to 4.8 volt. So the current is constantly seen in the millimeter. Are you clear? Now we are going to plot all the values here. Now this collecting electrode potential must be taken in the x-axis, and the photoelectric current must be taken in the y-axis. If you plot all the values, clear. For example, for 0.2, the value is how much? 0.078. For 0.6 also 0.078. If all the values are plotted, you will get the straight line graph. You will get the horizontal line. Are you clear? You will get the horizontal line in the graph. Are you clear? Here all the values to be plotted with respect to the x-axis value and the y-axis value. You will get a straight line. Here the current is saturated. Are you clear? Now we are going to see the most important part, second part. Are you clear? Now the most important part is, with the help of the potential divider arrangement, what I am going to do now, here I am going to change the polarity. Are you clear? Now negative potential must be given. Negative potential must be given to the anode. Very important. Negative potential should be given to the anode. Instead of positive, negative potential must be given to the anode. Are you clear? This one becomes positive. Cathode becomes positive and anode becomes negative. Are you clear? Look at the value here. Now no voltage is given. Even for no voltage, the same amount of current is shown in the milliammeter. Now with the help of the potential divider arrangement, already the polarity is altered. Now the value of potential which is given to the anode, it becomes minus, look at the table, 0.2 volt. Usually anode should be given with positive potential. Here anode is given with negative potential. That is the significance here. Anode is given with minus 0.2 volt. What will happen? These highly kinetic energetic electrons, no, they are emitted from the cathode, no. This highly energetic electron, so clear, they are trying to reach the anode, but here negative potential is given. All electrons, they are having negative charge, so they will, so clear, try to reach, but some of the electrons, they will be reaching the anode. Few electrons are repelled. Why they are repelled? Because, so clear, here negative potential is given. Very few number of electron alone, they will be reaching the anode. Because of that, the current is reduced to 0.059. Are you clear? So 0.059 milliampere will be shown. The current value is decreased. Are you clear? When anode potential is minus 0.2 volt, the current value is decreased. Now I am going to increase the, what is the potential now? Minus 0.2 volt is given. Now the current is, negative potential is increased. Now the negative potential is increased from 0.2 volt to minus 0.4 volt. Now the 0.4 volt is given to the anode. Now what will happen? Still few number of electrons will be repelled, very less number of electrons will be reaching. Therefore the correspondingly the current will be decreased to 0.039 milliampere. Now I am going to increase the negative potential from 0.4 to 0.6 volt. Here the negative potential is increased. Therefore, what will happen? More repulsion will happen. Very less number of electron alone will be reaching. Is it clear? And the number of electrons are reduced, no? Therefore, the number of electron reaching the anode is reduced. Therefore, the current is reduced to 0.019 milliampere. Are you clear? Now the final climax is very important. So in the climax, what happens? Now the negative potential is further increased to 0.8 volt. Are you clear? When 0.8 volt is given, what will happen? Look at that. More amount of negative potential is given. All the electrons, is it clear? All the electrons, I will rub it off. Is it clear? I will rub the actual condition must be shown in proper form. Are you clear? Here what happens? Now, this is the negative potential anode. All electrons will be repelled. Are you clear? All the electrons will be repelled. No electron will be reaching the clear anode. So when no electrons are reaching the anode, what will happen? The current, photoelectric current will become 0. There won't be any reading at all. So when minus 0.8 volt is given to the anode, no electron is reaching. Even fastest electron will be stopped by the negative potential. Are you clear? This particular potential is called the stopping potential. Minus 0.8 volt is called as what is the stopping potential, because this potential is able to stop the even highly energetic electron. Basically, it does not allow the electron to reach the anode. That's why this particular potential is called as what is this? Stopping potential. Stopping potential definition will be asked in the exam. Stopping potential definition will be asked in the examination. What is stopping potential? Stopping potential is the negative potential given to the anode, retarding potential given to the anode, which is able to stop the fastest electron. The highly energetic electron could be stopped with the help of the stopping potential. Are you clear? So these are all the very important definition and graphs may be asked in 5-mark question. Here I am going to tell you one important thing. Here the electrons, they are traveling towards the anode, no, they will have high kinetic energy. So this part to be completed here. If all the values are taken, if retarding potential is taken in the negative x-axis and photoelectric current is taken in the y-axis, again you plot, what will happen? The graph, it will be reaching like this. Here minus 2 is there, minus 4 is there, minus 6 is there. This is the 0.8 volt. So when the stopping potential is reached, when the stopping potential is minus 0.8 volt is reached, what is the photoelectric current value? Photoelectric current value becomes 0. Make a note, very important one. Are you clear? So at a particular potential, the photoelectric current becomes 0. Now I am going to tell you one important thing. Here the electron, they are having tremendous amount of energy, no? That electrons, they are having kinetic energy. I am going to write one important sentence now. This particular formula, what I am going to write, that formula is very much essential for all physical problems. To solve all the problem, that formula is very much essential. That's why I am going to write it elaborately. Look at that. Here, the electron, they are having kinetic energy. Therefore, how can we write the kinetic energy of the fastest electron? Are you clear? All the electron, they are having energy. The kinetic energy of the fastest electron, that is stopped by whom? This stopping potential VO. So work is done by the stopping potential. So the kinetic energy of the fastest electron will be equivalent to which one? Work done by the stopping potential. Work done by the stopping potential. Make a note. Are you clear? Kinetic energy can be written as half mv max square. The electron which possesses the maximum kinetic energy, it should possess the maximum velocity also. Therefore, half mv max square should be equal to work done by the stopping potential. How will you write the formula for work done by the stopping potential? That can be written as EVO, electron charge, into the potential which is applied to the anode. Are you clear? Half mv max square is equal to EVO. So this is the formula. By using this, plenty of problem will be asked. Already I have told that the intensity should not be altered. Now this particular intensity, the present intensity can be taken as I1. Are you clear? Now I am going to increase the intensity. Now we will see what happens when the intensity is increased. Now if you increase the intensity, the photoelectric current will be slightly higher. So the photoelectric current will be slightly higher. When you decrease the potential, so clear, in this direction, or if you increase the negative potential, again the graph, it will reach the same point. So clear, the second intensity, which is given to the intensity of the intensity is increased to I2 from I1. What will happen? The graph, it will be reaching here. It shows that if you increase the intensity, photoelectric current alone increases, but stopping potential is not altered. It shows that the stopping potential is independent of the intensity. Though intensity is increased, again exactly stopping potential will be the same. So this conclusion is very important, may be asked in the objective also. Stopping potential is independent of the intensity. Here I2 is greater than I1. Compared to I1, the intensity of the second radiation is greater, but no change in the stopping potential. Photoelectric current alone increases. Okay, so be thorough with the concept, may be asked in the 5 mark. Okay.